Okay, good evening all. On behalf of Delhi Economic Society, I welcome Dr. Jyotirmoy Bhattacharya, who is with the Ambedkar University, Delhi, uh, for delivering this lecture on DSGE models in macroeconomics. In fact, our association goes long way. I think Jyotirmoy came to do masters in 1999. We entered JNU in 1998. And since then, we were staying together in the campus. And both of us have done our PhD with Professor Prabhat Patnaik. We shared a lot of thoughts, a lot of time, and so on. Jyotirmoy is considered to be one of the brightest students of CESP, and he's extremely bright. You will see in a moment. On top of that, we became colleagues in Ambedkar University briefly when I taught there for 2 semesters. And Jyotirmoy is teaching macroeconomics in Ambedkar University, and he is covering this new Keynesian tradition of macroeconomics, including DSGE models. These dynamic stochastic general equilibrium models have a lot of impact on the policy, particularly when I was in NIPFP. That time, one team within NIPFP, in collaboration with one team at the RBI Mumbai, they were trying to develop some DSGE model in the context of India. So, I was not familiar with this tradition of macroeconomics, as well as the know-how how to do it using MATLAB and Dynar, particularly empirically, if we have to test in Indian context, we need to do data analysis. So since then, I was extremely keen to learn this tradition of macroeconomics. Since Jyotirmoy is already teaching for some years, I requested him, and we were discussing also informally that at the undergrad syllabus of macroeconomics in our country, particularly in Delhi University and in other universities, this tradition is yet to find its place in the economics honors syllabus. However, worldwide central banks all over the globe are using DSGE-based models for inflation targeting and so on. I don't know whether Jyotirmoy has noticed or not. Last week, I think Rohit and Indranil Chaudhuri have written one paper in EPW. It's precisely this new Keynesian versus post-Keynesian debate in inflation targeting and so on. So this is very much in thing in the policy debates all over the globe. However, in our country, at undergrad syllabus of macroeconomics, it is yet to be incorporated. So that's why I thought it would be some basic discussion on the DSGE models in macroeconomics would be extremely useful for all of us. And I couldn't think of any better person than Dr. Jyotirmoy Bhattacharya to introduce us to DSGE models in macroeconomics. So we are extremely grateful, Jyotirmoy, for your time and for I know you are extremely humble person, and you are so sincere, and at the same time perfect gentleman, I would say, who immediately agreed to deliver a lecture for Delhi Economic. He is very much part of, he is our insider, he is very much part of Delhi Economic Society. So without further delay, I would request Jyotirmoy to take over. And Jyotirmoy, you can take your time, so there is no hurry as such. And after your lecture, maybe we can have a question answer session of around half an hour or so, if it is fine with you. So over to Jyotirmoy.
Thank you, Shreya. Thank you for the introduction, and thank you for inviting me, because I have been I joined the Delhi Economic Society maybe as soon as it was launched. So it's also an opportunity for me to participate in greater depth in its activities, and I hope that this forum will actually become stronger and grow as time goes along. And talking of DSG models, as Shreya was saying, that we are students together in CSP and so on. And we used to hear a lot DSG and similar methodologies. And we are always very curious, ki, what is this all about? And as time went on, we got a chance to study and learn about these things. And at the outset, I want to say is that my own attitude towards this tradition of modeling is a sort of ambivalent. I don't find it convincing in many ways, but also I can see how the profession ended up here. So the idea is that yes, there are kind of many things which are, to put it simply, very strange about this framework. But this framework is also a result of following a certain kind of logic. And so to get out of it also requires us to examine that logic. And that's what I'm planning to kind of try to do today, that to see the kind of paths we have followed to end up here, and then take stock of where we are. Planning to speak for around maybe an hour, and then actually the says that we can have a discussion following that. So I will also stop from time to time in between, and we can have kind of quick clarification, and then major discussions we can have at the end. So DSG model, this is the structure of my talk. So why DSG? The real business cycle. So in the DSG tradition, the two major models are the real business cycle models and the new Keynesian model. As Shurajita was mentioning, the new Keynesian model is a model that is very much in use by bankers, central bankers, and others for monetary policy making. But as we'll see in today's discussion, it is really a derivative of the real business cycle model. So, in fact, in my lecture, I'll be spending more time on the real business cycle model to see what it does. And then the new Keynesian model will follow as a kind of a subsequent development. Finally, talk about how it's used in policy and some treaties. So DSG model belongs to the class of business cycle models. So macro, one kind of classification that we do in macro is that it's partly growth theory, where we discuss long-term growths, and partly it's business cycle theory, where we discuss shorter-term fluctuations in the economy. Now, I would like to argue at the outset that any model of short-term fluctuations, business cycle fluctuations, has to be a dynamic stochastic general equilibrium model, right? Why so? Well, it has to be dynamic. I'm not saying anything, and I'm saying obviously, because when you're talking about business cycle, then automatically it's a dynamic phenomena, right? You're thinking of ups and downs of the economy. So things are evolving over time. So any model you build of it also has to have a time dimension. Any model also things has to evolve. Only then you can see how the economy uh, fluctuates, why it fluctuates, and what are the causes, etc. So any model of the business cycle has to be a dynamic model. But it is worth noting that a lot of the models we teach in class in our undergraduate courses, ISLM, its extension ISLM, ASAD, Phillips curve, etc., they are in the tradition of Keynes's original work, general theory, which deals with a short period, right? So in the Keynesian short period, we look at a time where all stocks are frozen. So capital stock, etc., is frozen, money stock is frozen. All expectations are frozen. And then you look at the equilibrium of the economy, right? So that can be a starting point, but that model by itself cannot be a model of the business cycle because you're looking at equilibrium at a point of time. So that doesn't answer why the economy goes through ups and downs. So one can think of taking a short model and then extending it and then connecting into a sequence of periods and so on and have a dynamic model. But a short period model by itself is not a model of the business cycle. It can be a building block, but by itself doesn't tell you that why the economy actually undergoes fluctuation. If it's in equilibrium, why doesn't it stay forever in the same equilibrium and nothing changes, right? Why do we see economies fluctuating? So Shurajita just mentioned, I've seen the paper by Rohit and Indranil. I've not had a chance to study it. But say, for example, Kaleshki, ultimately Kaleshki is building a dynamic models, right? Many dynamic where you have things happening over a sequence of periods. And therefore, you can ask questions about the trade cycle and so on. And so that's the direction that any theorization in whichever tradition of business cycle has to move, that you have to have a multi-period dynamic model. The stochastic, by the way, is just a fancy word for random. So why should it have to be stochastic? Now, stochastic, like deterministic, you could say it's obvious. Dynamic, you could say it's obvious that it has to be dynamic. Stochastic is not so obvious because one could have a model of fluctuations which is purely deterministic. So if you remember, I don't know whether nowadays we study it or not, but at least when we were a student, we used to study things like Hicks's model of the business cycle, where things would go up, you would hit a ceiling, you would come down, you would hit a floor, you would go up, and so on, right? So you can think of building a model where the system itself generates its ups and downs. For example, when people started studying and collecting data on business cycle phenomena in the 19th century onwards, the initial models were actually sort of deterministic, or what you would call the endogenous fluctuation model. For example, one kind of story that's we are not going into the character of the story, just want to give you a style of the story, is that at some point when the economy is doing well, there is optimism. When there's optimism, there's a lot of investment. A lot of investment means there's a boom. As the boom happens, slowly the capacity that you're building up exceeds demand, so capacity utilization starts to fall. When capacity utilization starts to fall, slowly businesses find that they're not making profits, so they cut back on investment, so the boom turns into a recession. And as time goes on in the recession, because of natural growth of population, etc., demand again picks up, capitalization again starts rising. Firms see that times are becoming better again, they start to invest, and another boom starts, right? So in this case, the boom and recession are kind of causing each other. So that's a deterministic theory of a business cycle. And one can build many more such theories. Early on, a criticism against that kind of model used to be that, after all, business cycles don't follow any regular periodicity, right? So booms and recessions, there's no fixed time. It's not like a pendulum that will come back and go forth in a fixed amount of time. So people used to see the business cycle things are much more irregular and so on. So how can a deterministic model actually explain the business cycle? But nowadays we cannot say that, because with chaos theory and so on in the late 20th century, now we know that even relatively simple dynamical, deterministic dynamical systems can have very complex behavior. So a deterministic dynamical system doesn't mean that it has to go in a very simple oscillatory periodic motion. It can have pretty complex motion, right? So we cannot say that just because the business cycle has a period, a complex ups and downs, it cannot be deterministic. It could be. And at least in the 1980s and so on, a lot of people actually spent a lot of effort trying to build, trying to use chaos theory and so on to build business cycle models. So all we can see at the moment is that right now there are no good candidates. So logically, there could be a completely endogenous deterministic theory of business cycles, but right now we don't have any good candidates for that. So right now, the alternative framework that everyone follows is that of propagation mechanisms plus shocks. So the idea is that you model the economy as inherently stable system, right? And then you say that, but the exogenous data of this economy has a random nature. And because the exogenous data is fluctuating, therefore the economy's endogenous variable are also fluctuating. And that is what the business cycle is. So basically, we break up our analysis of the economy into a set of exogenous shocks, which are the exogenous data which are fluctuating, and endogenous variables which are fluctuating in response to those shocks. For example, the result business cycle model, on which we'll spend quite some time today, is a model in which the technological productivity is the exogenous variable which undergoes kind of fluctuations. And as a result, the endogenous variables like employment, output also fluctuates, right? So sometimes when I'm trying to explain this, I give the example that, on one hand, you have a pendulum or the solar system and so on, which kind of has a periodic motion which is driven by itself. That would have been an endogenous business cycle model, which we are not doing. Instead, I give the example of a musical instrument or even your own desk that left to itself, it is stable. It's not carrying out any kind of motion. But then if I knock on it, so you can think of the knock on the table as something kind of exogenous, then that causes the table to vibrate and there are fluctuations. And if the table is going to be hit constantly by a series of knocks, then the table will also fluctuate. And of course, your table and say a drum, they will produce different sounds because the structure of the system is different. So therefore, how the system endogenously responds to the shock also tells you about how the system is put together. So this response to shock is also a way for us to understand the construction or the functioning of the system, right? So that is the model, that is the standard model right now, in the absence of any kind of alternatives from the endogenous fluctuation side, the standard model of studying business cycles. That the economy given by itself is a stable system hit by a continuous series of exogenous shocks to its exogenous variables. So if that is so, then everything becomes random because the exogenous variables are random. The endogenous variables, which are function of the exogenous variable, also become random. So we need to use the theory of randomness. We need to have a stochastic model. Finally, another reason why we need to have a stochastic model is that it is like a observed reality that households and the firm face uncertainty about their future prospects, right? So I don't know, for example, in the very basic thing, how long I'm going to live. So today, if I have to decide, how much I should save and consume, one very important variable will be how long will I work and how long will I live. And I know next to nothing about these two variables, right? So even if it is completely deterministic, maybe there is some kind of advanced scan that some futuristic world can do of me and tell me you are going to live for N years. I don't know that data. So at least whether the real world is deterministic or uncertain, the fact is that households and firms, where they're making that decision, actually face uncertainty. And therefore, you have to have a way of modeling this uncertainty and how they are going to respond to risk. So anyway, you need a stochastic model. So both to model the environment that households and firms find themselves in, and to kind of model the fact that the economy is fluctuating, we make our model stochastic. So dynamic, some argument, stochastic, some argument. Finally, why does it have to be general equilibrium? So general equilibrium is the equilibrium of all agents, all markets. So all agents is again kind of obvious. It's macroeconomics. It's a theory of aggregates. So all agents has to be taken together. All markets, at least the three markets that I'm listing here, which we all study traditionally in macroeconomics, the goods market, the credit market, the labor market. These three markets surely have very high degree of interconnection, right? The standard things that we study, that you sell your labor in the labor market, the earnings that you get is what you spend in the goods market, the credit market determines how much of it you save and consume. So at least in terms of these major markets, there is no point studying, one market at a time. In the end, if you want to understand business cycle fluctuations, you will have to study the simultaneous equilibrium in all these markets. This is not to say that particular equilibrium or particular sectoral analysis has no use. We can always build small models to study specific aspects separately of the goods, labor, or credit markets. But in the end, when it comes the time to explain the business cycle phenomena, then we have to bring all these markets together and get a complete picture through a general equilibrium. So far, therefore, I'm arguing that whatever be your methodology and so on, you need some version of a dynamic stochastic general equilibrium model to study the macro. Now, here comes the first thing, that when you say DSGE model in macroeconomics, we are not talking about this. So what I have talked about so far is that in a generic sense, any model of business cycle has to be dynamic, stochastic, and general equilibrium. But when in our everyday usage, we say DSG models, we are not talking about this fact. We are in fact referring to a specialized class of model, right? Because there are any number of ways you can build a dynamic stochastic general equilibrium model. But DSG model in today's usage really means RBC model and its descendants. So therefore, we can see that, the macroeconomists are very good at naming things. And they name things in a way that seems that, what they're saying is very natural. One thing that we all said, natural rate of unemployment and natural rate of output. So if you say DSG, then who can refuse? Yes, models have to be DSG. But the DSG models that we actually mean when we talk in the literature about DSG is a particular class of model, which is RBC models plus various. I've written a various imperfection, but we can even say various extensions. So you take the RBC model as your base skeleton, and then you add on various things. And the class of models you get from there is DSG. So first thing we'll see is, again, remembering back to our student days, we studied general equilibrium, right? From a very great practitioner of general equilibrium theory, Professor Anjan Mukherjee. And then after general equilibrium class, when you went to study DSG, you said, oh, this is not general equilibrium in that sense. Because when you studied general equilibrium in the micro course, then everything was really very, very generically defined. You have a utility function with very minimal restriction. You have a protection function with very minimal restrictions and so on. The macro DSG literature, on the other hand, specializes things to a great extent. It assumes a particular kind of utility function. It assumes a particular kind of protection functions. So it's a very specific, narrow class of models, right? So even if methodologically you agree that, modeling has to be DSG modeling, that doesn't tell you whether this particular specialization is the right specialization, right? It may work, it may not work. But this is a particular special case of this broader methodological approach, right? But this is what a lot of people are doing. So let's see where it started and what it is. So what is the RBC model? RBC models became popular, I think, late 70s, early 80s. So RBC model is a real representative agent, optimal growth model, right? So it's a model where there is one representative agent. We'll talk about that agent in a bit. And the agent is optimizing, maximizing utility. And we are interested in the kind of growth that you see from it. So if at some point you have taken a look at the Ramsey-Cass-Coupons model, so you can think that this is a extension of this. So just to go to a little bit of the history. So Ramsey developed this model basically looking at an ethics question that among many generations, should be the best kind of allocation of resources across generations. And then macroeconomists and growth theorists took it up as a model of actual growth. So you can think of a RBC model if you're coming from that kind of reading. Then you can think of a RBC model as a Ramsey model plus uncertainty and plus labor leisure choice. So it's a Ramsey model with uncertainty and labor leisure choice. That's all that a RBC model is. So it assumes that there is a single infinitely long-lived agent, right? So this agent represents the entire household side of the economy. There is one agent. So this agent is kind of a representative because it's kind of encompassing or representing the entire household size. And this agent decides how much in each period to consume and how much to work. And the goal is to maximize the lifetime utility. Remember that this agent is infinitely long. So their objective function looks like this. So the U you see here, U, CT, NT. So CT is the consumption in period T. NT is the labor supplied in period T. U, CT, NT is kind of a per period utility. So the NT will actually reduce utility. More labor you supply, we assume that there's a disutility from work. So more labor you supply, less utility you get. More you consume, the more utility you get. So U is increasing in CT. So U, CT, NT is a per period reward function that this agent has. We add it up over all periods. So T is equal to 0 is when we are starting. We go on to T is equal to infinity. So we add it up over all periods. But we don't simply add it up. We multiply it by an additional factor, beta to the power of T. Beta is a constant between 0 and 1. So because it's less than 1, so the higher and higher power you raise it, the smaller and smaller beta to the power of T would be. So what beta to the power of T, it's called the subjective discount factor. What beta to the power of T is doing is it's saying that the future periods are given lesser and lesser and lesser bits. So yet another way of saying the same thing is that our household is impatient, that it gives higher weightage to periods closer to 0 and lower weightage to later periods, right? Captured by beta. So we add up, but we don't add up simply. We add up as a kind of a weighted average where future periods get a smaller and smaller weight. Finally, because our world is a world with uncertainty, so CT and NT will also be random, right? How much you can consume in the any future period T or how much you will work in any future period T is not known to you at time 0, right? So they're uncertain. So how do you evaluate such uncertain paths? So we calculate the lifetime utility for each path and then take the mathematical expectation over all possible paths. So that kind of implicitly two kinds of addition. One, we are adding up over time, the summation that you see here, T is equal to 0 to infinity. And we are also adding up over all possible paths that the world can take, which is given by the expectation operator. So E is subscript 0 because we are taking the expectation as of time 0. So standing at time 0, looking forward to the rest of your life, you are taking the mathematical expectation over all possible paths which are possible. So we are assuming that there's a single household which is maximizing a utility function like this. Now, this can be questioned at various levels. First of all, representative agent. So again, if you go back to your microeconomics lectures, then you will see that the conditions under which multiple agents can be aggregated and that aggregate will behave like a single agent are very, very restrictive. So if you again want a strict theorem that I want to prove that my economy can be captured by representative agent, then that theorem will have very stringent conditions which are unlikely to be satisfied in the real world. Basically, it has to be that everyone has the same preferences, and moreover that the utility should be various things. As the income is multiplied, the share of different goods should not change. Very restrictive assumptions. So strict aggregation will not be strictly correct most of the time. Unlikely that it is right. Expected utility formulation itself has been questioned. The people who have empirically studied decision making and uncertainty. So expected utility again coming to us from microeconomic theory, where we say that a decision maker and uncertainty, if their preferences satisfy certain axioms, the von Neumann Morgenstern axioms, then they behave as if they are maximizing expected utility. But experimental work on people's decision making and uncertainty shows that those axioms also are often violated. So expected utility theory itself has come under a lot of challenge. Finally, even if you were to accept both, if you look at a formula, the formula takes a particular form, right? You could have otherwise said, okay, I have a utility function over my entire path. So I have a u from C0 to C infinity, and then I'm somehow taking an expectation of it. But here, instead of that, I'm assuming it's a very simple, what I call is additively separable form, that there is a per period reward function, and the lifetime utility is just a sum total of the weighted per period reward function. And the weighing itself is not just some arbitrary weight. I could have said, okay, there's a weight for each period which is decreasing, but decreasing in its own way. Instead, the weighing itself is given by a geometric series. So therefore, even if you accept that there is a representative agent, even if you grant that expected utility can be applied, even then you are extremely simplifying your model by saying that the utility function used to evaluate things is same in every period apart from discounting, and this discounting takes a particularly simple form, right? Infinitely long-lived also, one can question that no agent is infinitely long-lived, so can your representative agent be infinitely long-lived? Again, we all know, say in neoclassical macroeconomics also, you study things like the overlapping generation model, where people are not infinitely long-lived, and the results come out different, right? So again, in a very orthodox and mainstream macroeconomics also, there are other ways of doing this. So one can always question that, why are we doing it this way? And those would all be valid questions. And also those would be questions that people have tried to address. So it's not as if people's attention has not gone here. Each of these assumptions that we are saying here have been relaxed, alternatives have been tried, and so on. But at this point, I would say that I would not kind of give up on this right away. Because in a way, while it's an extreme simplification in so many ways, it is capturing something essential to macroeconomics. That macroeconomics has at its core intertemporal choice. That a lot of the choices that we are doing in macroeconomics is a trade-off between today and tomorrow. Right? Here we are seeing in terms of the household, that you consume today or you consume tomorrow, whether you consume or you save. And while the basic RBC models won't have this kind of intertemporal choice for firms, firms also face the same issue, that do I invest? Do I increase my capital stock? Do I reduce my capital stock? What do I do? So because so many of the key macroeconomic questions, consumption, savings, investment, are questions about today versus tomorrow. So it seems to me that even a very simple formulation of that question might actually give us some insight. So of course, while we can question and try to improve on this, I don't think that this is completely useless as a starting point. That this at least gives us some idea, some framework where there is a genuine intertemporal choice, and then we can see that what kind of choice do we face, right? So while these questions are there, one, they are addressed within the RBC kind of, not correct, RBC style of modeling. And secondly, while they are problems, they are not fatal problems. I would say that the model still has something to tell us. On the production side, we assume perfectly competitive firms. And we say production occurs by a standard neoclassical production function. Looks like this. So YT is equal to AT, F, KT, and T. So your F follows all the standard neoclassical assumptions, and diminishing returns, etc., all of that. Important here is AT. So AT is multiplying a production function. So AT is a measure of productivity. High AT means high productivity. Low AT means low productivity. So in real business cycle theory, AT is where you bring in your randomness. So you assume that AT is not deterministic. AT has a random component. So you can argue in various ways why AT is random. So it's called technological shocks. So technological shocks can be purely technological shock. You can say technological progress need not to have a kind of smooth path. Technological progress happens through partly by chance. So technological progress can have a kind of a uncertain and random path. Also, this can stand for anything which happens to a supply side, because you can think of technology broadly and not just in a scientific or engineering sense, but you can think of technology as everything which determines your mapping from inputs to outputs. So that mapping itself can have a random component. Various things can happen to your economy which affect the ability of the economy to produce output. So all of that is captured in the technological shock. But the important thing to remember is that this is the place where randomness enters into our model. So AT is the thing which is going to fluctuate. Now you have to solve the problem. In solving the problem, solving the model, one issue comes is that there's a chicken and egg problem. That basically agents decision depends upon the expectation of the future, right? Say, take the simple problem of, how much capital should I accumulate? How much do I save? So to decide that, I have to know what returns I will get on my savings, right? Now, returns on savings ultimately come from rewards to capital. So that depends on how much capital there's going to be in my economy tomorrow. But how much capital my economy has tomorrow depends on how much people save. So savings of everyone together determines how much capital there's going to be tomorrow. But until I know how much capital is going to be tomorrow, how do I know whether saving is worthwhile or not? So there seems to be, we are caught in a kind of a problem. Or to put it in another way, you can say that, beliefs determine actions. Action determines the outcome. And it is the outcome about which you have to form beliefs. So somewhere this cycle has to be broken. The way this literature breaks it is by the assumption of rational expectations. So rational expectation says that agents' beliefs about the endogenous variable in every future state of the world equals its true equilibrium value in the state of the world. So rational expectations is an assumption of equilibrium between beliefs and outcomes, right? So as we said just now, beliefs produce action, action produce outcome. We are saying that the beliefs and the outcomes coincide, right? That what you believe actually happens. We are looking at only such configurations, only those we are calling equilibrium, right? So there's nothing. So this is not, I'm not doing the alchemist that what you believe will necessarily happen for you. I am saying that I will look at only those configuration of the world where this works, where people's beliefs and the outcomes are really matching up. Any other configuration, I am going to not look at, right? So this is the equilibrium condition that I'm imposing, that I'm going to look at only those configurations of beliefs and actions where the two match. So in a way, this is like our usual practice in economics of looking at conditions in which supply and demand match. Right? So again, there is nothing in the laws of physics which says that supply and demand have to match up. At some point, they may not match up. But we kind of implicitly, so we don't model always the process, but we implicitly believe that there will be economic processes which will bring supply and demand to equality. And we somehow kind of put our faith in those processes and say that this process will work fast enough. So there isn't much loss in looking at only the configurations in which supply and demand are equal. Similarly, here we have implicit that if beliefs and actions and outcomes don't match up, people will adjust in some ways. And we are taking a leap of faith, then that adjustment process are good enough that there is not much loss if we look at only the states where the adjustment is no longer required, where beliefs and actions are matched, right? So, couple of things to note here. Some of you might have come across in, again, micro or mathematical economics of the cobweb model of a supply and demand world where supply and demand keep chasing each other and they don't converge. Similarly, for rational expectation, a lot of people have modeled learning process that, okay, suppose my belief is something, with that belief I take a decision and the outcomes come and they don't match, so I revise my beliefs. Then will this process ever converge? And in many situations, you find that the process never converges. It explodes, or it keeps going round and round. So all of that is possible. So therefore, this faith is not backed by any model. If you put it in the model, sometimes it will converge, sometimes it will not. Rather, you are saying that in the real world, it is quite likely that convergence will happen. So I'm going to look at it. So that's just a modeling choice, which may be a good choice, maybe a bad choice. But before we go on, important to note that this is not perfect foresight, right? Because the beliefs are for every contingency in the world. So you say the world can have these three scenarios, and this is what will happen in each of the scenarios. So I may not know which scenario will occur, right? So I'm not saying that I know what will happen in the world tomorrow, but I know all the possibilities. I know the value of the endogenous variable in all the possibilities. I know the probability of all the possibilities, right? So rational expectation still leaves space for risk and uncertainty. The only thing is that all the contingencies can be enumerated and completely understood, and the understanding will correspond to what's happening in the equilibrium. Secondly, as I said, that macroeconomists are very good at naming. So rational expectations is not a consequence of rationality. As we said, that that's a sort of equilibrium condition that we as modelers are imposing. And rationality doesn't really imply that you have to have rational expectations. Sometimes in informal discussions of this, people try to justify rational expectation by saying that you cannot fool all the people all the time. But first of all, that's not a theorem, right? A lot of people can fool all the people all the time. There's, again, it's not some law of nature that you cannot fool all the people all the time. Secondly, by saying that you cannot fool all the people all the time, you are kind of trying to say that people will catch up and wisen up. That can be convincing in a world which is stationary, but a world which is itself dynamic and uncertain, right? There is nothing fixed to learn, right? And especially because what you're trying to learn is not some law of nature, but the behavior of other people who are themselves learned, right? So you can keep chasing each other forever, right? Because while I am trying to learn what you did yesterday, today you are doing something else because you are also learning, and so on. So you can fool, we can all fool each other all the time because we are all changing and we are all dynamic and so. So in the kind of environment macroeconomic where we are applying this, neither is it a theorem nor a consequence of rationality, nor also necessarily very plausible that people will ultimately converge to a rational expectation. So I would say that rational expectation, while it has become again a very standard practice in macroeconomic modeling, is not without its problems because very hard to justify once you start thinking about it. Other problems with rational explanation also, that you can have multiple equilibria, right? Because again, I am trying to forecast not just the state of nature, but what other people are doing. So there can be multiple things to which we can converge, right? And that's also possible. So we don't know how people pick up the correct one. So in a way, these problems are similar to the problems we face with the notion of Nash equilibrium in game theory, because that's again the same thing, that I choose my best knowing what you are doing. You choose your best knowing what I'm doing. But in a one-shot game, there's no way to know what you are doing, right? So how did we reach at the Nash equilibrium? So again, the same kind of puzzles occur in game theory. In both cases, we don't have a clear-cut answer. Why we should take this modeling assumption seriously. And so in both cases, a definition. If you define Nash equilibrium, I can calculate it. If you define rational expectations, I can calculate it. But there's no convincing answer why it should be interesting in terms of what happens in the world outside. Okay, but good thing about this RBC is that the equilibrium is Pareto optimal. So the allocation matches the social planner's problem. So solving things is easy. I just kind of solve the social planner's problem. So apart from the other conditions, I impose this equation of motion for capital. That capital tomorrow delta is the depreciation rate. So capital tomorrow is the undepreciated capital 1 minus delta KT plus the fresh output minus what I consume. And you get various first order conditions. So because this name occurs in many places, just to mention Euler equation. So Euler was a mathematician much before the beginning of modern macroeconomics. So Euler was solving dynamic optimization problems arising from physics, geometry, and so on. But this kind of equation has still got its name. But basically, this is MRS is equal to MRTS kind of equation. So on the left-hand side, you see the marginal utility from consumption today. On the right-hand side, for a second, ignore this expectation. You have the marginal utility from consumption tomorrow. So if I were to take this UC CT plus 1 to the LHS, then I would get something like a MRS, marginal utility from consumption today upon marginal utility from consumption tomorrow. And this term in the square brackets here, AT plus 1 FK plus 1 minus delta is the MRTS. They're the terms at which consumption today can be converted into consumption tomorrow. So basically, this equation is saying that on an optimal path, MRS must equal MRTs. That the rate at which people objectively are willing to substitute between consumption today and consumption tomorrow must equal the terms at which your technology allows you to convert consumption today into consumption tomorrow, right? Otherwise, you are not at optimal. If these things are not equal, then consumers will either consume more today or more tomorrow until they are equal. This is just your standard calculus first order conditions, except that because consumption, employment, everything tomorrow is uncertain, so this holds in the expected kind of mathematical expectations terms, that the utility today and mathematical expectation of marginal utility too. So this is one first order condition. The other is a labor supply condition, which is easier to understand. This is also MRS is equal to MRTS, that UN by UC is ATFN. So UN is the disutility from work, UC is the utility from consumption. So if I work one more unit today, my utility goes down by UN, but that allows me to buy ATFN because that's the marginal utility of marginal productivity of labor. So ATFN number of extra units of output I get, each of which will give me utility UC. So again, unless this condition holds, I will supply more labor or less labor. So this is like the supply curve of labor, which determines how much labor I am willing to supply. So together with this, I solve the model. So now this model, when you solve it, seems to give you something like a business cycle. So suppose that 80 goes up. The 80 is random, it's fluctuating. So 80 goes up means productivity has gone up. So initially I was happy working a certain amount, producing a certain amount. Now suddenly my marginal productivity will go up because 80 has gone up. So if I was getting a certain marginal disutility, now my disutility is less than my marginal productivity. So I will be happy to supply more labor, right? So think of a farmer and suddenly the rains are very good. So if the rains are very good, farmer feels ki if I put in some labor, my benefit will be more. So farmer will go and spend more time on their farm, right? So if marginal productivity goes up, I will supply more labor, more capital. I will also save because this is exceptionally good times. Tomorrow will not be so good. So I will try to transfer something there into the future. So there will be investment. And if 80 goes down, everything will happen in reverse. So qualitatively, RBC seems to produce something looking like a business cycle. So it's a plausible model of the business cycle. But one good thing about macro today is that it's not enough to give a qualitatively plausible answer. People would also like to know whether your model can predict the correct magnitudes, at least roughly. No one is making exact predictions in macro, but at least the rough magnitudes produced by your model should match what you see in the data. And I think that's a major development. If you say what has happened to macro since say Second World War, it's a big thing which has happened. Right? Now it's no longer enough to tell a story. The numbers have to be at least in the correct range, if not exactly right. And RBC model faced a problem there. First of all, initially, so their initial claims were that technological shocks could explain 80% of US business cycle. But when people measured TFP more precisely, they found that TFP fluctuations were too small to explain the observed output fluctuations. Their model had no unemployment at all, right? So people supplied more or less labor, but everyone was kind of reducing hours and increasing hours. You could do various things in the model to generate employment by bringing in various kinds of non-convexities. But whether you talk to unemployment or in terms of hours, the problem was that the fluctuations in hours produced by the model was too small. So either you got too small a change in the labor input, or you have to assume that labor supply was very elastic, which did not match up with micro data. So there also the model had a problem matching up the quantitative results. Great Depression cannot be explained. So someone joked that it should be called a Great Vacation, because in this model, if you want to model the Great Depression, you have to say that 80 had fallen by a lot. So people had realized it's not a good time to work, so they had stopped working. But that doesn't really match up with any of the kind of observed behavior of people in the Great Depression. They were not taking a Great Vacation. Financial market data also seems to contradict the model. So when you look at asset pricing, and again, the same kind of MRS conditions hold in asset pricing. So again, this model finds it difficult to explain asset prices and the market price for risk and so on. So as a result, people very quickly abandoned the RBC model. So it came up in the 80s. I think by the mid 80s, it was practically finished. But people have retained this as the skeleton on which to build other models. So while the RBC model as such as an explanation, so this explanation that business cycles are just an optimal growth model responding to productivity shocks, while mostly people don't take that seriously anymore, they have kept this modeling framework and tried to build other models around it. And while one can think of many kind of sociological and so on reasons for this, one very simple and plausible reason is that it's a simplest neoclassical DSGE model you can write. If you're going to build a complicated neoclassical DSGE model, you will have to start from something which looks like the RBC, right? Because you'll have to have household, you'll have to have firms, right? You'll have to have some markets where they can interact. So you'll end up starting with something like which looks like RBC. So I think I will take 2 minutes here. Any quick clarificatory questions, deeper discussions you can. So you can maybe write your questions in chat or ask.
Or you can unmute yourself and ask directly.
Yeah.
So how do you account for a real life scenario where we as persons do not really have that choice of how much to work and how much to consume? But let's say somebody else, maybe my supervisor or employer, decides on behalf of me how much I should put in, how much effort I should put in. So is it that society as a whole is deciding on this, and that is what we would be taking as a representative consumer choice?
No, not really, because see, again, we don't decide our hours. So that is one kind of shortcoming of this model, is that it said that hours per worker fluctuate. But usually, of course, part-time work and so on also is very narrowly defined. So if I take a job, I have to go work 8 hours at an intensity defined by the job. But on the other hand, who works and who doesn't work, there's a lot of choice, right? One of the issues that we discuss, for example, is women's labor force participation. So some women are choosing to work, some women are choosing not to work. Similarly, when you think of young people and they have to decide whether I go in for an education or I not, again, they are choosing whether I work or I don't work, right? So labor ledger choice, yes, there is some kind of a non-convexity that if you decide to enter the labor market, then the menu of choices available to you is very limited. But there are many ways that will decide whether I should be in the labor market or not. And all economies show a lot of fluctuations there. Secondly, while I will touch upon it briefly, once we start modeling unemployment, then we realize that unemployment at the individual level is also a choice because you can find some job or the other. So when you're unemployed, you're mostly kind of waiting to see whether there's something better turns up. And again, people are making economic decisions, cost benefit calculations to see that. One thing which kind of we are taught often is that in an underdeveloped country, you don't have unemployment because people cannot afford it, right? That automatically tells you that it's a choice. In very poor person loses their job, they will find some economic activity, makeshift, whatever, to make ends meet. So therefore, I think that labor ledger choice does exist, but it doesn't exist on kind of what we call the intensive margin, that you don't say that I work 6 hours or 5 hours. Rather, it works at the extensive margin that people decide whether to work or not to work. I think some other people have raised their hands, so maybe you can unmute and ask.
Okay, hi Jyotirmoy. Am I audible? Shantanu
Yeah,
here.
Shantanu, you're audible. Yes.
Jyotirmoy, thanks for the presentation so far. But just a bit of a clarificatory question. As you mentioned, and this is the question which is there in me for quite some time. This RBC is, one can say or one can argue that this RBC is some kind of a model which deals primarily with the supply side. That is, it
Yeah.
deals with the technological shocks, leading to business cycles and so on. On the other hand, the DSGE, which is an extension of the NK understanding, NK framework, is primarily, not exactly along the lines of the typical Keynesian school, primarily catering to the demand side. So, philosophically, how can these two actually can be reconciled? That's what that will be my question. Thank you.
Okay. Okay, Shantanu, maybe I can keep your question for the end because I think once we see the
sure.
NK, it may become clearer. But just to kind of one quick mention is that while we'll see NK, it has really nothing to do with Keynes. So new Keynesian model is not a Keynesian model, so it's a misnomer. So anyway, we have to see it as a descendant of RBC rather than thinking of it as anything connected in any simple way to what Keynes did. So maybe right now anyone has any clarification about the logic of the model and then its place in macro we can take in the final discussion.
Yes,
Pranita has a question.
Yeah, hi, Professor. So my question is a more basic sort of a question. So in the beginning, as you said, when it comes to the very classification of between, say, stochastic models and deterministic models. So I was wondering, I am kind of curious. You obviously, I know there's much more to talk about deterministic models. As you said, you didn't talk about it right now. So I was wondering whether maybe towards the end or maybe right now, if you could talk a bit more about why is this widespread rejection of the deterministic models there. I understood like the example that you had given. However, I was also wondering whether having stochastic models in place allows like by the definition in modeling itself, it allows you to escape the recognition of any kind of pro-cyclicality existing. And because you can always say that okay, these are exogenous shocks, and that's the whole theory kind of based on. And so just to recognize that okay, even within the randomness, there is a pro-cyclicality. There are actions that lead to this booms and bust cycles. We can see it in different contexts, right? Even in the US, for example, we know like what the Federal Reserve has been doing even since the beginning of the 20th century. 21st century. And otherwise also. So yeah, I was wondering if you could talk a little bit more about both about the logic of applying that, as well as the philosophical aspect of it, but also more so the practical logic. There would be a reason why. I'm guessing like according to my limited understanding, I think my assumption is that stochastic goes more well with neoliberal and neoclassical aims also, right? In a way, because
I differ a bit here. I differ a bit. One is that, see, no one has really given up deterministic. So all the time, economists and well-regarded economists have kept coming up with various deterministic models of business cycles. Secondly, so maybe some will actually take off at some point. Secondly, stochastic doesn't mean that we are completely giving up on agency, because see, the stochastic is only about the exogenous variables, but how the economy responds to that depends upon how your endogenous variables behave. So ultimately, stock is only half the story. The rest of the half is the propagation mechanisms, that how your economy is responding to the shock.
yeah,
And that depends on behavior, including behavior of policymakers. So stochastic model, for example, maybe again this discussion we can come back to at the end, that we'll see new Keynesian models, and there's one of the major components of the model is the policy rule of the policymakers, and different policy rules lead to different outcomes. So ultimately, as I said, that when you hit on this table and when you hit on another table and the sounds are different, that is because the build-up of the table is different. And the build-up in the economic model is the behavior of the economic agents, including policymaker in the economy. So I don't think that there's a politics to it, right? Because see, I can make a stochastic model. One of the kind of good or bad things that happened in economics here in the last 50 years is that we have kind of come to the conclusion that methodology and politics are kind of independent. That from any methodology, you can produce any kind of political conclusions. So in a way, we are enjoying a degree of freedom that earlier we felt, even say in the early days of rational expectation, as well as the rational expectation was predisposed towards certain kind of policy recommendation. Now, as a theorist, we feel much free. That if you want to come to some prejudiced final conclusion, you can reach it in neoclassical, non-neoclassical, anything can show anything. So now we are kind of that. Therefore, I would disagree with that. It's predisposed to a certain policy conclusion. Either model can be made to work in either. So maybe I go on and then we'll come back at the end to the
so
other.
may I like add just one part to
Yeah.
the question, if I may?
Mhm.
So just to go back, I mean, I understood your point about the latter thing I was saying, but just to go back a little to what I was saying. So, but this thing, right? I mean, having this, dynamic stochastic general equilibrium model, it does allow you, like methodologically itself, as I said, it allows you to escape any recognition of, as I said, any pro-cyclical movements. I mean, I'm just putting it in a way because
No,
not to
you
sound
cannot, because see, ultimately your policymakers are part of the model. Policymakers are in the model.
And also, one very important thing is that see, because when we know that when it comes to an economy or a business cycle or anything, production is the main thing, right? I mean, your more productive forces, your mode of production, your productive forces, technology, these are very much the core things. So if a model that takes productive forces itself in the form of exogenous factors only primarily, like technological shocks and I mean so that, and which is why I was also curious about the deterministic, as you said, maybe people have not yet come up
so I
with
think see, these are bigger and maybe philosophical questions. So let's come back to that in the end. So because I think that when we see another,
I was saying
just
we can use
excuse me, Pranata, let him continue with his
presentation. I think I
plan.
overrun. So I will come back again. But I think we need to look at the new Keynesian model
at the end.
Okay.
Yeah, because these are major questions. So we'll come back to them. But let me present the other variant, because once you have two models, also it may be easier to contrast what's happening.
Okay.
So the new Keynesian model is an extension of the RBC model, which turns it from real to nominal by adding nominal rigidities. So we assume that prices and wages don't always immediately respond. So the way we do it is, we assume that earlier we had perfect competition in the production side. Now we assume there is monopolistic competition. So firms are now price setters. Whenever firms have market power, they will set price. And we assume that the economy has some friction which prevents prices from immediately changing when economic conditions change. So traditionally, this used to be called menu cost. So the menu cost term came because there was cost of reprinting menus and so on. But menu cost actually economically can be of many kinds. There may be cost to collecting information. There may be cost to taking decisions. So firms don't always want to decide what's the best price and so on. So for many reasons, firms will not immediately change prices. The firms will not immediately change prices. Then when the demand curve shifts, they will change quantities. They will supply more or less, right? And here again, monopolistic competition helps, because if you had perfect competition, Then you would have price equal to marginal cost. So if you try to sell a bit more, then the marginal cost will be more than the price. So you're making a loss. So you won't do that. But if you are in a monopolistic competition, then you're charging a markup over marginal cost. So now you have to sell a little bit more. Then on the additional unit, you're not making any loss. So you don't mind. So in part, it also kind of ties up to what Shantanu was saying, that in some sense now demand has a role to play. That now nominal demand had a role to play in a RBC also, because see, it's an equilibrium of the consumer and the firm. So ultimately, the first order condition where the MRS condition. So something happens to the consumer side. Say consumer becomes more impatient or the utility function changes, then the equilibrium would change in a RBC model also. So I wouldn't say that RBC model is a necessarily supply side model, because like any neoclassical equilibrium model, it's a mixture of supply and demand. Here also, but here, because of the stickiness, something like your standard Keynesian model aggregate demand starts to appear, in a sense that now when demand changes, the quantity responds to demand instead of the price. And this allows us to have monetary non-neutrality in the short run. Money has a role to play. And also these are models which are interesting. This is like my side interest. Sure, don't know that my PhD was on foundation of monetary economics. So my side interest was that, today we are living in a world where money as a medium of exchange is becoming less and less important. We are actually most of the time transferring credits and debits to make payments. So one interesting thing about new Keynesian models is that they actually fit into this world, that they don't need money to be a medium of exchange. All they need is that there be some nominal rigidity. So a monetary but cashless economy is what these models can very easily fit. That your all transactions are purely credit and debit transactions. And as long as some prices and wages are rigid, the economy would still have a role for monetary policy. So the unit of account money becomes the key thing in this. So a lot of the early discussions about this new Keynesian model was so-called the three-equation version of this model. So in this three-equation version, a very specific assumption about pricing was made, that in each period, a randomly chosen fraction of firms gets to change its price and others can keep it fixed. So this actually is purely a convenience assumption, that you say that if you choose randomly and independently chosen, then you don't have to keep track of who changed prices when, because anyone can be asked to change prices anytime. So this makes our modeling much easier. This is completely unrealistic and one of the things that people want or are working to change in this model. But a lot of textbook versions will take this assumption because it makes things very easy to derive. So it's completely a kind of kids version of the new Keynesian model, not to be taken seriously at all. But if you do this, you end up with what is known as the new Keynesian Phillips curve. So in this Phillips curve, pi is the inflation rate, and it depends on tomorrow's expected inflation rate and the output gap. YTN is the national level of output, the output which would have prevailed in a version of this economy with completely flexible prices. So the gap between that and the actual output is one driver of inflation, and expected inflation is the other driver of inflation. Now, I would say this is a very misleading equation, because this kind of equation you get only if you assume Calvo pricing. Because this B, ET, pi t plus 1 seems to suggest that people care about tomorrow's inflation. They do not. When the firm is setting the price, it really cares about the cost conditions for all future periods, right? Because I'm setting the price today. I don't know when my turn to reset the price will come again. And so I have to think about what cost and the price of other firms will be like for the indefinite future. But with the Calvo assumption, things kind of cancel out and simplify, and you get an equation like this. So in the three-equation model, this is equation number 1. The other equation is so-called the dynamic IS curve, which is just the Euler equation for the consumer that we saw before. And the third equation is a policy rule. So you get something like this. So now we say that nominal interest rate is some function of the inflation rate, some function of the output gap, plus some constant, plus a shock. Shock is any part of the monetary policy which is not determined by these factors. Turns out that if you have all these three equations, then together you can try to solve for all the endogenous variables in this model. The standard technique is you log linearize. So you convert all variables into log variables. Then you linearize using Taylor's theorem. Then it becomes a linear algebra problem. You put an additional condition that you want to look at only bounded solutions where inflation does not shoot off to infinity. And nowadays there is very standard software called Dynair, which can very easily solve this model. So Dynair is a program which is built on Mathematica, not Mathematica, MATLAB or its free version Octave. And to use Dynair, you don't really need to know even MATLAB or Octave. Dynair has its own language, which is very close to how economists would write out ordinary models. So writing a model in Dynair does not require you to know any programming. You just state the equilibrium condition in a model and Dynair can solve them. So solving this kind of rational expectation model has become really, really easy. It's like a turnkey thing that you just write down the model and you solve it. And if you Google it, you'll find already many Dynair models for standard textbook versions. So you can also pick up a Dynair model and modify it and run it. Also, in today's discussion, I'm not talking about how these parameters of these models are estimated. In a real application, you'd want to estimate the parameters from data. So Dynair can do that as well. So many of the standard estimation methods are built into Dynair, so you can feed in the data and it can estimate the parameters. So computing wise, things have become really easy. So we solve it somehow. And people use it for all kinds of monetary policy simulations. Now, again, the specific answers you get depend on the specific model. But some general implications of this kind of modeling for monetary policy emerge. One is that we have to evaluate policy rules and not discrete actions. Why? Because our model is based on rational expectations. A lot of my decisions are based on my expectation of the future. So I care about what the monetary authority will do tomorrow. What it is going to do today. See, ultimately, the monetary authority in any country nowadays controls very short-run interest rates. So what it does today is going to affect me in a very small way. What I really care about it is actions over the entire future. So I form expectations. Because I form rational expectations, so I need to know how the monetary authority actually will respond to different states of the economy. Right? So therefore, when you hear about inflation targeting and so on, the exact rules that they promote, they may not have that much of kind of theoretical backing. Right? But what has a backing is that you have to choose a rule and not decide every day. That you have to choose a rule, you have to choose a policy regime rather than a policy setting each day, and then transparently communicate that regime to the private sector so that the private sector can correctly anticipate and form its expectation. So I think this is one of the major impact it has had on actual policy making. Inflation targeting and so on was an extremist position, and that has been kind of moderated in many ways. But the idea that the central bank has to choose a rule, and it is the rule we evaluate, I think that is a kind of a deeper conclusion which is here to stay. That central bank's performance can be evaluated on a day-to-day basis, or its policy cannot be chosen on a day-to-day basis. The central bank has to fix a rule and then stick to the rule and communicate them. The second, which is a peculiarity of this model, is so-called Taylor principle, that to get a unique stable equilibrium in this model, the policy rule that we saw, these parameters, phi pi and phi y, they have to have a certain range. And the conclusion which comes is that they have to be high enough. But if phi y is 0, then phi pi has to be greater than 1. So for any inflation, phi pi was the coefficient of the inflation rate. So we are saying that nominal interest rate must respond more than 1:1 for the inflation, for the economy to be stable. Now, one thing I want to mention in today's discussion is that sometimes, particularly when things have improved perhaps, but at one point, these models used to be presented in a way which were palatable to people raised in the ISLM PC kind of framework. So used to say, okay, the PC corresponds to a PC. So you had a Phillips curve, now you have navigation Phillips curve. The IS corresponds to dynamic IS. In fact, naming is also chosen like that. So what is actually an Euler equation from a dynamic optimization problem? You're calling it the IS curve. And then your LM curve corresponds to a monetary policy rule. And then people used to think in the ISLM kind of logic. Because see, ISLM is easy to understand. It's a single period model. So you would say, okay, now I understand why the nominal interest rate has to be higher, because inflation is happening. Unless I make my nominal interest rate higher than the inflation rate, how will my real interest rate go up? And how will aggregate demand go down and so on? So people are doing ISLM in this problem, but that's wrong. The reason the Taylor rule holds in this model is purely mathematics. And when you're solving this model, you said that you are looking at only bounded solutions, right? So when the Taylor rules hold, phi pi is greater than 1, then all solutions except one become unbounded. And because you chose that I am not going to look at unbounded solutions, therefore you get the result that only one solution remains, because all the other solutions are still there, but they have become unbounded. So you're arbitrary, or maybe if not arbitrary, at least when not that well argued choice that you are going to not look at unbounded solution is what gives you a unique stable bounded solution. Basically, the central bank blows up the economy. It says that if you deviate a bit, I will deviate even more, then you have to deviate even more, and then the economy will blow up. And since no one wants the economy to blow up, or no one thinks that the economy can blow up, again, it's not wanting, it's thinking, imagining, expecting. So since no one expects the economy to blow up, therefore the only solution which is possible is where there's no deviation to start. Right? So given that this plays such an important role in finding the solutions in this kind of methodology, I think that the idea that solution must be bounded should have been justified more by behavioral or institutional or some kind of assumptions, but it is not. Just solving the process, you just put key, okay, I'm not going to look at explosive solution. And that is what leads to a lot of the policy results. So this is a bit unsatisfactory that the policy results are driven by a methodological choice which is not so well defended. But in any case, these models have to be seen from the lens of RBC and rational expectation modeling and not by somehow naively mapping it onto ISL and PC. Okay, so NK models have a huge number of problems empirically. Apart from whatever methodological problems you may have with it, empirically also they don't do well. Calvo pricing is very far from reality. People now have access. I hope at some point we'll have the similar access in India to the microeconomic data which is used for calculating price indices. So they can actually look at the price changes at the individual commodity level, and they find that the frequency of price changes is not constant. Depending on economic conditions, the variability of price change goes up, goes down. Firms which change the price are not selected at random. Firms whose prices are the farthest away from the price of other firms are ones which change the price more often. Prices are not really very, very rigid all the time. And now we all shop online and so on. We know that prices change every day, right? So there's no menu cost actually. If you take any commodity and look at its price on Amazon and tomorrow you look at it again, you'll find that the price is somewhat different, right? So there is no nominal rigidity that we see at least for prices. And people argue that maybe it's not prices, but wages which are rigid, in which case, of course, we should have modeled it that way. So price rigidity, at least for commodities, is not so easy to find. And when people collect this kind of microeconomic price data, they find that prices go up, prices go down. So there was also a notion that prices cannot go down. That's not true. Prices go down very frequently. There are many discounts, sales. Again, we as shoppers know this, but more systematic data collection also shows this. So this whole focus of not modeling wage rigidity, but modeling price rigidity, that doesn't seem to be holding up very well. The NKPC has been questioned. And again, Rohit has done some work on this in our kind of community. Other people have also worked on this. And NKPC, the particular form that depends only on future inflation, that is not true. Real world inflation has inertia. Past inflation also determines present inflation. If you look at the NKPC, then there is no pi t minus 1 in this equation. But when people take this to the data, pi t plus pi t minus 1 seems to play a role in inflation dynamics. So inflation has inertia, and people who actually do applied new Keynesian modeling, therefore make some ad hoc assumption that, okay, some of the prices are indexed. But which are the prices? Where are they which are indexed? No one knows. It is just an assumption made to patch up the model and the data. Similar other patch ups have to be applied. So for example, consumption investment don't immediately jump when economic conditions jump. So they assume something called a habit formation, which is just again an ad hoc patch up to make consumption inertial. Borrowing constant matters, so that has to be added. So new Keynesian economics has not done very well by its own standards. But people who practice new Keynesian economics, when they test it, they find a lot of problems. And if a justification for all this modeling was that this is more principled, right? So when you think of, say, neoclassical macroeconomics or other macroeconomics, one defense of neoclassical macroeconomics, which is sometimes given, is that at least it is more disciplined. That there is a certain methodology and you follow whatever the methodology leads you, you're not making ad hoc assumptions. That is at least not the case with New Keynesian and RBC models. That if you want this model to perform well empirically, if you want it to match up the data, then you have to make a whole host of ad hoc assumptions, right? Which you cannot map back. Because see, what is again the story that we are told, that micro-founded macroeconomics is that you have a lot of microeconomic kind of evidence or observation about individual households and firms, and you take that as your starting point of your macroeconomic modeling. But a lot of this ad hoc patchwork that we are doing to make our new Keynesian models match the data are not corresponding to any microeconomic observations. Like this habit formation, it's not observed at the microeconomic level. We apply it to our models to patch up our model and make its macro implications match the macro data. Similarly, for this price indexing, we don't really show you that, okay, these fraction of prices in your economy are indexed, so it's reasonable to assume price indexing in the mic. But no, you see that the inflation has an inertia, you want to patch it up somehow. So you say, okay, price index. So this whole idea that this methodology is more disciplined and more principled doesn't really work out if you want to really match the empirical data. Often you are doing various ad hoc patchworks to make things happen. More serious problem with the NK approach to monetary economics is that it doesn't have a very good story of the cost of inflation. Right? So if you're in the new Keynesian model, the inflation is bad only because causes price dispersion, because not all prices are moving at the same time, so prices get dispersed, goods are not properly allocated, and so on. So if you talk to the person on the street and ask them that why do you hate inflation, they are not going to answer in these terms, right? People perceive the cost of inflation in a very different way. So again, another justification of new Keynesian or neoclassical macro used to be that because they are starting from microeconomics, so the objective function you are giving to policymakers is not arbitrary. That ultimately you are asking policymakers to maximize people's utility, which has a kind of a grounding. But if your model doesn't have a good model of the cost of, say, inflation, then again you cannot therefore say that what should I do to money, what kind of other cost should I take on to reduce inflation, because I don't really know why inflation is costly, right? So again, if your model of the microeconomy is not very good, right? Because see, micro-founded macroeconomics cuts both ways. That if you have a very good model of microeconomics, then it will be good macroeconomics. But if your microeconomics is bad, then the macroeconomics will be equally bad. So if your microeconomic level you have not correctly modeled why inflation is costly for people, then at the macroeconomic level you are not really guiding policy from a principled position. Right? So that's the biggest problem right now with the new Keynesian model. So now that we move towards kind of summing up, one thing is that what I have discussed is again only the very basic textbook version of both these models. There's a vast body of literature and all kinds of things have been put into this model. A lot of work on financial frictions, heterogeneous agents. So not all these models nowadays are necessarily representative agent models. Search and matching in the labor market to model unemployment. Preferences which are more complex. One of the critique was that the utility function is too simple. From the beginning itself, people have looked at more complex preferences, more realistic price setting schemes than simple calvo pricing. So one is that it is incorrect that we take a very simplified textbook version or classroom version and judge the model. In the actual research literature, a lot of the things, again, see, I think that, like I have also been critical just now of these models, but sometimes we are kind of see this as camps, and somehow we think that the people in the other camp are necessarily stupid. So I think that's the thing that we have to get out of. That if any criticism of the model is very obvious, then it is obvious to other people, and we have to assume that other people are also acting in good faith and they will try to fix those things. So many of the obvious criticisms people have tried to fix and they have worked and fixed to more or less success, which is true for all kinds of economics. Right? There's no kind of style of doing economics which you can say has been unqualifiedly successful. All of us have problems. So obvious problems people have tried to match. And so if you have to judge, you have to judge it by the best output and not by the simplified textbook models. For example, a lot of work is happening on heterogeneous agent new Keynesian models, where people are actually modeling borrowing constraints, asset illiquidity, and therefore they are saying that one is that they are dropping the representative as an agent assumption. Secondly, they are saying that therefore wealth distribution in the economy is important, not just for people's welfare, but even for understanding things like the effect of monetary policy. Because if you have different agents with different portfolios, some of who are borrowing constraints, some of who are holding illiquid asset, then two things will happen. One is that how many agents are in each group will determine how a policy will affect things. For example, if people are borrowing constraint and you suddenly give them a tax cut, then they are anyway waiting to consume. They could not borrow. So if they get a tax cut, they will consume a lot of it. Whereas if you have agents who are not borrowing constraint, then they might save a lot of the tax cut. So how a tax cut will affect your aggregate output depends on how many people are borrowing constraint. So distribution matters not just in itself, but even for macroeconomic questions. Secondly, macroeconomic policy itself may have distributional effects. So monetary policy, its role may not be just to change your aggregate output or inflation. It may also change the distribution of wealth in the economy by affecting different people differentially. So there is a whole lot of work going on in this area, which is one way in which people are responding to obvious shortcomings of this basic framework. However, I would say that the core assumptions are very hard to relax: optimization, rational expectation, simplicity. So as I said, people are talking about illiquidity, credit market constraint. After the 2008 crisis, a lot of work happened on financial intermediations. But ultimately, the financial markets remain to some extent simple. And no one really knows how to kind of move beyond this, the difficult kind of problems. And therefore, I would say that, this is an ongoing research program. To say that nucation, and we have discussed how many ways that RBC and nucation fail empirically. So say that we are an nominality itself, etc. So to say that we have kind of ready-made instruments which you can immediately apply to policy or questions, I would not be so optimistic. I feel that this is an interesting research kind of project, or increasing research kind of approach, which needs to go further and maybe question some of its basic assumption. Again, people are doing that and thereby become more mature. So I will stop here and we can have a discussion. So some basic readings, surveys, etc. Some of them are more recent, some are old textbooks. So I think that this presentation can be shared with all participants. Thanks.
Yes, I have already done that. Thanks a lot, Jyotirmoy. I think I downloaded the presentation from your Facebook page and circulated in Delhi Economic Society WhatsApp.
Thank you, Shreya.
So people will get access to this. Now it's time for discussion and questions and so on.
Professor, I have one question.
Yeah, sure.
First of all, good evening,
Maybe,
Professor.
Shweta, can I collect, Praful, just a second. Shweta,
Yeah,
we
yeah.
can collect some questions and
Absolutely.
then answer.
Yeah.
Yeah, Praful, please.
Yeah, so first of all, thank you so much, Professor, for this lecture. This is my first DSG model lecture, and I'm starting my PhD under Dr. Sana Roy Chaudhary. So my question is very basic. I have a limited knowledge that, so I have a research problem in my mind related to subnational debt. So, or 2 or 3 more research problems. Now my question is how to think about this problem and to start connecting the research question statement to structure of DSGE model. Like how to, like, we understand the basic and the all the equations, all the forms agent and everything, but based on my research problem, how do I start thinking so that my research question connects to DSGE model and my outcome is based on that model?
Sure. So maybe we can take some more questions and then I can answer.
Yes.
Thank you.
Thank you.
Roneta, would you like to come back now?
Maybe later. There is one question in the chat that can be.
Okay, I will just take a look.
Yeah, what is the Abhishek? Abhishek, are you there? You can ask also directly.
Yes, sir. I am here, sir.
Yeah.
Sir, just I read lot of the DSGE model paper, and this is an interesting lecture on these days. I working on last the 4 years. Sir, I have a doubt in the setting the new Keynesian Phillips curve. There is the one is the way of the Colbo model pricing, and one is the Rotenberg. But why are you using this model is final goods firms and the intermediate goods firm instead of the just like as sir putting the Colbo modeling pricing to determine new Keynesian Phillips curve, sir?
Sure.
Any other question?
Hello, sir. My name is Manoj Jha. Am I audible?
Yes.
Yeah, you're audible.
Yeah, my name is Manoj Jha. I'm doing PhD under Dr. Ganesh Manji at IIT Jodhpur. I'm doing DSG modeling, not stochastic, DGE modeling of the climate change and the role of institutions in that. So, do I need to log linearize the every equations in the, like I have taken the household sector, firm sector, climate sector, and the government sector. So do I need to log linearize everything, and how do I do that in the MATLAB or in the Octave or Dynair? Can I have the codes or anything? Please explain.
Sure.
Any other question?
Yes, my question would be that how do you see the actual monetary policy making by RBI? Let's say they did something yesterday in the light of these models. I mean, this world seems to be very different from the way actual policy is done, where it is by a few committee members who take a judgmental view of trade-off between inflation and output and decide on that.
Should I answer these and you can come back? No, someone else had a question.
Somebody.
Actually,
Shantanu.
Shantanu here again. Sorry.
Yes.
Yeah,
Actually,
Sure.
a small question that if I mean, by and large, what I understood is that these discussions or these models are primarily meant to explain a closed economic framework. Now, if it is extended to an open economy with volatile capital flows, then what happens to this? Let's say the interest rate rules or the inflation equations. I mean, can this be extended? Then this particular equations be applicable in the context of open economy with global capital flows, volatile capital flows? Thank you.
Jyotirmoy, maybe you can try to address these questions, then
okay.
we can take another set of.
So Praful's question, I think, is working on subnational debt and how to proceed with these models. So again, this I can only give a generic advice at this level because I don't know exactly what questions you're looking at. Is that as we proceed in research, you have to find templates, you have to find other people who have worked on similar things and then amend. Because again, general advice to anyone working on the PhD that it's not useful to try to invent everything from first principles. So find existing templates and modify them. And then you have to ask that is the framework really useful for your question? Because see, these models, as I discussed, are really most applied for business cycle fluctuations or monetary policy. So if you're thinking of debt sustainability in the longer run and so on, I think the first thing you have to examine by looking at the literature is this framework really the best framework for this? Right? Because it may be that the questions you're asking are not really fitting into this framework and maybe some other framework is necessary. So that I think the literature has to be your guide, and of course you'll have your supervisor. Abhishek, final goods and intermediate goods.
Jyotirmoy, sorry to interrupt.
Yeah.
Can you please stop screen sharing?
Yeah, sure. Yeah. Actually, I want to show a couple of equations back and forth.
Oh, sure. Then go.
Like for example, for this question only, the next one, Abhishek. So if you look at the way we started the new Keynesian world, we assumed imperfect competition, right? So Abhishek's question was that what is this business about intermediate goods and final goods? So when you say imperfect competition, then I should have actually made it clear here. What we do is that the RBC model was a one good economy. Here we say that your economy now has multiple goods, right? Sometimes you say multiple variety of goods. And the consumption good is a composite of those goods. Because see, if you have imperfect competition, there has to be multiple goods. A single good, otherwise you'd have just a monopoly. So many goods and many firms. And then these goods are put together into a basket which the consumer consumes. So then when writing down this model, there are two choices. One is you can say the consumer themselves put together this basket. So consumer goes and into there's an infinity or n number of varieties and they buy some amounts of each. Or as a modeling judge, you can say there is a final goods firm. Final goods market is competitive. So the final goods buys from these imperfectly competitive firms and assembles into a final good. So the main point here is that the consumption is a composite good. Whether this composition, putting together, you put a final good firm or let the consumer do it, that's a purely modeling choice. But important part is for monopolistic competition, you need to have a variety of goods. Okay, Manoj, question about climate change and does it need to log linearize? Again, we'll have to look at a particular literature. So how you solve this model? So log linearization is one way of solving this model by turning it into a linear difference equation system. So if you are going to log linearize, one is that pen and paper method is also possible. A lot of people do it. There's a book called ABC of RBC, which has all kinds of recipes for doing log linearization in pen and paper for your equations. If you are using Dynair, then Dynair does log linearization for you. So you write down your nonlinear equation and Dynair can log linearize. And Dynair can also be used for deterministic model. So model doesn't have to be stochastic to use Dynair. So if you are going that way, if you choose to log linearize, then either do it automatically by Dynair by setting up your model in Dynair, or pen and paper for small models is also feasible. Question is, do you want to log linearize? Because see, when you're log linearizing, then you use Taylor theorem. Taylor's theorem works only when your variables are close to the point around which you are doing the Taylor expansion. So they work only for small fluctuations. So for example, in the macro literature, people have studied the nonlinear model directly and say that, okay, what happens if you allow for big fluctuations, which log linearization cannot deal with. So I think that the modeling choice that you have to make, that do you want to look at only small fluctuations around the steady state, in which case log linearization is a valid technique, which you can apply manually or using software. Or do you want to look at a bigger deviation and more kind of flexible dynamics, in which case you have to find some way of studying the non-linear system, which will be harder, but which may be necessary for the questions you're asked. So again, something you have to think with your supervisor. Dipankar's question was that what does it mean all this for policy making in the world actually as this happens? I would say in India, the kind of the high point of this was the Urjit Patel committee report, which was in a way, a lot of the things was like when a verbatim taken from all these textbooks of new Keynesian economics. And that's when the inflation targeting came in. But I think both in India and in the world, the adherence to a very rigid theoretical framework has not happened. Why has it not happened? One is, as we can see, that there are a lot of problems with the framework. So I think it's not happening is not necessarily a bad thing. That if the model is not doing very well empirically, why should mighty policymakers put too much emphasis on it? But I think secondly, and this is something which interests me, is that see, ISLM PC was something that people can understand, whereas these people cannot understand. Because there's a big difference, and there's a difference I see also when I'm teaching these models with students, is that people are naturally very inclined towards mechanistic explanation. X hits B, that hits C, then Y moves up. So they want this kind of causal mechanistic stories. Whereas the rational expectation model, you are looking at a path which satisfies certain conditions. You don't say how that happens. You say, okay, I want a path which is bounded, which satisfies these equilibrium conditions, and then whichever path comes out, comes out. So there's no mechanistic story behind it. So I think policymakers and common people, people who are not that much indoctrinated into the model making tradition, really love models where there's a story behind it, where they can say, okay, this, then that. And therefore, I think a lot of policymaking in the world, even when it pays lip service to the rational expectation models, ultimately is done by people who are thinking in ISLM, MPPC kind of terms. So those models have still had a hold on my imagination, even if formally some research department brings out papers like this. Finally, Shantanu's question on the open economy, there is open economy new Keynesian models. Right? So formally speaking, you can always extend it to an open economy. So you finally change your equilibrium conditions to allow for capital flows and goods flows. And in the financial market, you impose some kind of interest parity condition and then see where it takes you, right? And of course, all the usual thing we know in open economic, macroeconomics like impossibility lemma, etc., will make their appearance in this model. But again, the problems are the same with the problem of the domestic NK model, that we can't say that it's a very perfectly working model, but formally the extension is possible. There's a book by Schmidt, Grohe, and Uribe on open economy, macroeconomics, which does it in the new Keynesian RBC framework. It can be done, but quality we have to judge. How good is it?
Yes. Some more questions or comments or anything? If anybody want to intervene.
Yeah, I have another question, and there's also a question in the chat. So maybe you can
chat.
Yes.
Let me just check.
Oh, in the chat. Oh, Dawa. Dawa is writing something. Dawa?
Yeah.
Are you there?
Pranita, your question I cannot see in the chat. Shrita, can you see
No,
Pranita's question?
No, Dawa has written. Dawa, are you around?
Yes, sir.
Yeah, ask the question directly.
Oh,
I can
first
read
of
it.
all,
So
okay,
I
okay.
can read it. So
Okay,
see, you are asking that is DSG model really invariant? So again, that's a questionable thing, because you bring it up. I didn't mention that Lucas' critique was that it was a critique in part of the earlier econometric modeling practice, and the idea was that the correlation you found is specific to a certain policy regime. You change the policy regime, the correlation changes. So you are right that deeper models, the preference and so on may also change. So yes, one can, I haven't seen the literature, but in principle, I can see that something like this may happen, because ultimately preferences are not also fully exogenous. They depend on economic conditions. So that's true. Endogenous money and independent investment function. So interesting thing again is that endogenous money has won. So as I said that nowadays, these are all cashless economy models. So exogenous given money supply is no longer here. The government sets the kind of monetary policies for the interest rate. And to the extent there is something called money, it supplies endogenously determined. So I would say that all these new Keynesian DSG models are actually endogenous money models, right? Independent investment function, again, I think I was answering this when I was taking Shantanu's question, that see, I don't believe in this kind of dichotomy between the demand side models and supply side models. because all neoclassical models have a demand side and a supply side. So they will have an investment function, and that will combine with the supply side to produce equilibrium, which is true of any models. Right? So I would say that they have an investment function for sure, and they have investment decisions in the models. Now, whether methodologically you consider independent or not, I am kind of not very competent because I don't really understand this distinction between an independent and non-independent function. But investment behavior as a separate category of behavior surely exists in this. Pranita, your question has not come in chat, so if you can ask.
Yes, sir. So I have a different question from what I was asking earlier now. So it's interesting that if, as you said, that DSGE models are like the policy application of it is basically in monetary policy, right? And so I was wondering
Fiscal
how
also.
Fiscal also, okay. Okay, yeah, but like I think there was more emphasis on monetary policy decision making, right? Like by studying business cycles and taking lessons from that. I mean, in the presentation at least. So I was wondering that if how can we like reconcile, or like how do we apply this, for example, to what's happening in what's been happening in the US, in the US monetary policy? I mean, let's say ki since 2000s onwards, or just before the 2000s onwards, right? So, there is this thing known as the Fed put, right? The Fed put option. The fact that the Federal Reserve will bail out after every crisis. And in fact, that is taken as, that's one of the factors, I'm guessing. So I was wondering, how do we, I mean, we know that in the US, with the exception of maybe a couple of cases in the past, even say like 30 years or 40 years, like there have been mostly due to interest rates, right? Because of too much liquidity in the system and too much, that's why asset price bubbles have formed and certain things have happened. So I was wondering that how would we use this framework, basically just to understand more about the US policy scenario.
So again, this is something I did not touch upon in today's talk, but after the 2008 crisis, this became like the hot topic to work on. So a couple of kinds of works happened. One is that there was a lot of work, there was work before the crisis also on financial intermediation. That if credit markets are imperfect, then how does that enter into this model? And there was a work also called financial accelerator by Bernard K. Gertler and so on, which says that, it's again something, as I said about endogenous money, some of the things that we used to associate with heterodox, macro has become now orthodox. One of these things was that, investing your own cash is always easier for the firms because getting finance from outside has an agency cost. So therefore, how much you can invest depends on how much cash flow you have. And therefore, that creates an accelerator kind of mechanism that when times are good, firms have more on their own cash, then they kind of can invest more. And when times are bad, so that kind of amplifies fluctuations. So that and linking it up with model of financial crisis, that happened. One kind of work which happened a lot was what happens when the economy hits a zero lower bound, as happened during the 2008 crisis, because nominal interest rate cannot go below zero because otherwise people will just hold cash. So there was work on that. And fiscal policy started getting worked on majorly because generally before that in the US stabilization policy was monetary policy for various reasons. People said fiscal policy is slow to change and there's a whole parliamentary procedure and so on. Monetary policy is better. But when monetary policy ran out of steam because you hit the zero lower bound, then people have studied fiscal policy and also unconventional monetary policy. So all of that has happened. Again, we have to read and judge for our own how convincing we find it. But there's a big literature on each of these themes. Arun has a question that accommodating climate shocks.
Sorry.
I know that there is work, but I have not studied it, so I cannot really comment. But it has been studied. You'll have to look it up.
One small question I had on yeah. The heterogeneous, when you're talking about heterogeneous agents, do we mean that individual agents maximizing their utility? And is that what we are meaning, or we are still taking a social planner taking different kinds of representative agents?
No. We are thinking of individual agents. So we are thinking of a multiplicity of agents, each of whom may have a kind of different portfolio and different amount of wealth, and in an imperfect financial market, therefore, who may be making different choices. So actually, economy with more than one consumer instead of a representative consumer.
Okay, thank you.
Sir, I was wondering just one more thing, just a tiny technical question.
Yeah.
That so, like, I was wondering, so this, I mean, of course, so far, I mean, I don't think I've understood deterministic models so much. I mean, only stochastic to the extent that you've explained it. But I was wondering, you know, this thing of that, oh, like when things are good, and then just automatically things become bad. I mean, so I mean, I have not fully understood it. So, I was wondering if you could also like correct
Yeah.
me if
No, you are very right to be kind of unhappy with this, because let's come back to our basic structure that you have propagation mechanisms and you have shocks. Now, throughout this lecture, I have actually talked about the propagation mechanisms, how the system works, but I have not talked so much about the shocks. I just named the shocks that in the RBC model, you had a technological shocks. In the new Keynesian model, you can have technological shocks, monetary policy shocks. In either model, you can also have shocks to preferences. But economically, what do these shocks correspond to? Is, I think, a very valid question to ask, that really what are these shocks? Because these shocks are not really completely exogenous, right? When we said talking about the technological shocks in the RBC model, we said that anything which affects supply can be technological shock. Monetary policy shock, it's not as if the RBI is tossing points and so on. So this is actually a kind of a under studied, if I may say, aspect of economics, that we broke up our problem into propagation mechanism and shocks. But we have done a lot more work on the propagation mechanisms and much less work on the shocks. So I think that that is a valid question to ask, that we have to unpack these shocks. And actually there may be economics hiding there. That monetary policy shock itself may have an endogenous economic explanation and may not be exogenous and random in the same way. So I think that's a valid kind of critique or valid kind of shortcoming of how a lot of mainstream macros function. Again, not to say that no one has studied it, but it has been studied proportionately much less than studying the propagation mechanisms.
Yeah. So my question was actually
Pranita,
incomplete.
can I interrupt, please? Let
Yeah.
others also ask some questions. You
Yes,
can have a
yes.
discussion with Jyotirmoy later on, because there are other participants who would also like.
Maybe we can take a look at what you will have done, and we can have a discussion again some other occasion.
Okay, sir.
Mayurakshi has a question that can you please
Yeah.
discretionary fiscal policy in DSG models? Can we look at long-term growth issues through this model? Kindly provide a few references. Okay, I'm sorry, I don't have immediate references. If you send me your email ID, I can look up and send with you. So see, if you look at the long-term growth issues and so on, one is that one thing that I've not touched upon, which is very important and a lot of work still happening, is the interaction between fiscal and monetary policy. One is that I can just look at the fiscal policy here and say that, okay, government spends something that is taking away from people's consumption and how will people react and so on. That can be done. Interesting question is that are the fiscal and monetary policy interdependent? And there has been work on this even predating DSGE models, that you can say that, you know, if the government runs a budget deficit, then the monetary policy cannot no longer choose its monetary authority cannot choose its monetary policy freely. It must choose a certain amount of monetary policy to ensure that the government budget balances and so on. So then will the fiscal authority have a primacy that will choose the fiscal policy and the monetary authority will respond, or vice versa? So there's this whole discussion on this, as well as a fiscal theory of price level. So for that, you can look up a book which is called by Cochrane called Fiscal Theory of Price Level. For long-term growth, you see that these models are actually versions of the neoclassical long-term growth model, right? So this is a version of the Ramsey model and so on. So you can always use the long-term kind of growth model, which corresponds to the short-term. So in a way that these models, the macroeconomics of kind of short-term fluctuation and growth is kind of continuous, because it's the same basic dynamic framework. There you ask what happens to the steady state. Here we are asking what happens to the fluctuations.
So fiscal deficit can be thought of as a shock also, like a fiscal policy?
No, so fiscal policy, then just as we modeled monetary policy as a rule with a short term, you do the same with fiscal policy. Because see, again, as we know from even basic macroeconomics, that part of the fiscal policy is also endogenous. When times are good, government collects more taxes. Maybe it also feels inspired to spend more and so on. So then you would have, you know, government expenditure and taxes both with the endogenous part and a shock component. And then you put that along with your other equations into the model. Okay. Interesting question becomes that, does the government have a budget constraint? So neoclassical macro usually assumes that government has an intertemporal budget constraint. I have never understood why it has it. But if it has it, then what constraint does it put on the equilibrium of the economy? That becomes the next question to ask.
So indebtedness can also be thought of as a shock, or even that is part of
again,
endogeneity.
shock is usually we use in macroeconomics shock term for things which are unpredictable. That given the data at time t, the part of anything that you cannot predict is a shock. So indebtedness again will have a deterministic part, that if you have a certain amount of debt, then it will roll over to a certain amount and so on. So that can be one of the endogenous variables. So in a more elaborated model, you would have government debt as an additional variable, and that would have a dynamics of its own. So if that dynamics is an unpredictable part, then that will be a shock.
Yeah, something like in India, what we faced in during 2012-13. Let's say we tried to, do too much of an infrastructure given the size of the economy.
Yeah.
And then there was a twin balance sheet crisis kind of thing. Both the government as well as the private sector balance sheets were stretched. So should it be taken as a shock?
No, because see, that's predictable, right? So if you spend, you will have debt. So that's not really a shock, right? So you're following a certain trajectory. That trajectory, given that there's a government budget constraint of some kind, requires your trajectory to kind of bend in a certain. That if there's an upper bound on how much the government can borrow, then once you reach the upper bound, you have to go down. So that's all deterministic and given by the constraints. So that's not really a shock. That's the important endogenous variable and which can have macroeconomic implication. But shock is necessarily things which are unpredictable and exogenous. But the growth of your public debt is to a large extent endogenous.
Similarly, COVID period, should it be taken as a shock?
COVID is a shock. COVID is likely a classic example of a technology shock, right? Suddenly your production is shut down and what happens? So like COVID, I wouldn't say happy. I was going to say COVID would make RBC people happy, but basically that is the kind of thing RBC is built for. That you have suddenly unexpected situation which stops the production, and then what happens?
Okay, thank you.
Thanks a lot, Jyotirmoy. I'm sure it was quite a long session. He is speaking for almost 2 hours now. But it was extremely interesting and I would say thought-provoking because initially you have described what it is and then you tried to raise some criticisms about it and some limitations, some shortcomings of this kind of models. So now I guess those who would be working more closely with these kind of models, they would, and as you rightly said that not only the textbook version, but later on a lot of developments have taken place in the literature. So that way, practically those who are working with the data, even these people were telling me that micro level data, the way data is available in the developed world, we don't have that kind of data in India. So we had to make a lot of assumptions about them. But still people are working on it because I guess number one, as you said, it is more disciplined family of model as compared to other alternatives. And secondly, I think, taking clue from Dipankar's point, that actual monetary policy or following Robert Lucas Jr. Only surprises work. I mean, if it becomes predictable, even if it is model predicted, then it may or may not work. I don't know. But yeah, so we would continue this discussion. I guess we can have another session on similar theme. Maybe by you, maybe by somebody else, or maybe there could be a panel discussion also. Those who are working, some of the PhD students, and a lot of DU teachers and other teachers are there. If they think they can incorporate in their undergrad syllabus, part of it along with the other traditions. I think students should be taught all the traditions so that they can understand all the traditions and policy decisions based on those traditions, and then they can choose on their own that which one is more realistic, more rational according to their thinking. So yeah, so on behalf of Delhi Economic, you are part of Delhi Economic Society, so we must thank you for your efforts and for your time. And I would also thank all the participants and all the those who intervened actively, those who asked questions and gave their comments. So with that, let us close this session for today.
Thank you, Shreyata. Thank you for having me for this discussion. It was very great interacting with everyone and a lot of open questions which you all have to study on.
Yeah, thank you so much. Thanks a lot. Okay, so goodbye to all. We'll close this session. And I'll put up the recorded version in YouTube so that those who have missed today's session, they can access it later.
Thank you very much, Surijit and Jyotirmoy.
Thank you so much.